Okay, so what we are talking about today is limits. I just want to take a moment to kind of talk about what we talked about, particularly if you missed the other video of limits. We kind of talked about how limits are near, what's happening near something but not at it. So in a lot of situations, it's quite simple. You just look at, we talked about how this is from the left. So we start on the left and we move towards that x value. So we move towards this x value right here from the left. And as we're moving towards it, we're never going to really get to a y value of 3, but that's where it would wind up if there wasn't a hole there, right? That's really, I mean, sometimes that seems too good to be true, but of course limits get harder as time goes on, so don't worry. Just keep it simple right now. When we look at this one, we're starting from the right, so we're coming to 3 from the right side, and we're never going to get all the way to this dot, but we can see that the height of that would be 3, so that's why these limits are 3, and that's a y value. Since those two limits agree, the whole limit is 3, because both the left and the right limit equal 3, okay? And actually f of 3 is not defined, so there is no y equals 3. This hole is empty, but it doesn't mean we can't kind of see the writing on the wall, like see where the road is going, okay? Even though the road doesn't get there. So that's the general concept of a limit. So let's talk about, let's just talk about this for a second. There's 3 types of limits that don't exist. So limits that don't exist. Okay, the first one we've already talked about. That's when the limit as x approaches, I'll just say a, that's the value. The limit as x approaches from the left side does not equal the limit as x approaches from the right side. So to simplify, TLDR, left doesn't equal the right. Okay, the notation's kind of important, but this one we kind of talked about already. The second one that doesn't exist is going to sort of make sense. It's basically saying that if the limit as x approaches a, which is just some value, it's a number, right, of f of x is equal to infinity or negative infinity, that doesn't exist either. So we call this unbounded. So the short way to look at it is unbounded or infinite. The limit doesn't exist because infinity doesn't exist. I guess that's probably the simplest way to put it. So you can't say that the limit is infinity because infinity is not a number. So if the limit somehow becomes infinity, then the limit doesn't exist. So let's just take a moment. I'm going to say what 3 is, but we're not going to really get into that one. We're going to get into this one a little bit today. And I feel like we got into this one a little bit in the last video. And I'm trying not to drag this out too long, just try to get a little bit of the basics. The third one is the limit oscillates. So the limit as x approaches a oscillates. What does that mean? It means it just like wildly goes up and down. So here's an example. I'll just give you an example. What would be the limit as x goes to infinity of sine of x? So think about this graph. This is the graph of sine of x, right? And we know that sine of x looks like this. As we go to infinity, we could stop this ride at any point, right? We don't know whether it's going to be at a 1 or at a negative 1 or at a 0. We have no idea. As x gets bigger, y doesn't hone in on anything. It's just up and down, up to positive 1, down to negative 1, up to positive 1, down to negative 1. So if the limit as x approaches a oscillates, that's a third type. We'll talk about this one a little later, so let's not really worry about this one right now. And this one's a kind of rare one, the third one. You'll definitely need to know these three types. Let's talk a little bit about limit as x approaches infinity, or sorry, as as the limit that goes to infinity or negative infinity. Okay, so let's draw a graph. So we'll draw a graph of something that you're probably pretty familiar with, something that looks like this. This is a rational function. It's a very common, I think we can call it y equals 1 over x. And my question would be, what is the limit as x approaches 0 of this function of f of x of y? So let's take our usual approach. We'll come from the left side, and we'll try to see what happens as we get close to 0. Oh, it seems that negative infinity would be the answer, right? Seems like this is going to go to negative infinity. So it seems that the limit as x approaches 0 from the left of the function is negative infinity. Would we all be okay with that? A little thumbs up, nod, anything? Yeah? I mean, it seems that it's going to go to negative infinity. Can't really get there, but it's trying. Okay, as we come in from the right side, what do you think it is? The limit as x approaches 0 from the right side of the function is going to be positive infinity. Not a bad idea to put a plus there. So that's positive infinity. So this limit, does this limit exist, and why? There's actually a little bit, it's kind of a layered question. Does the limit from the left equal the limit from the right? So we say this limit doesn't exist. The reason that I would say it doesn't exist is actually because the limit from the left doesn't equal the limit from the right. So I would say DNE, the limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right, because this doesn't match that. Okay? So I sort of misled you a little bit, because you wanted to say it didn't exist because the limit was infinity, right? But the limit of this actually isn't infinity. It's not infinity. It's not negative infinity. They don't exist. It doesn't exist. They're both going different spots. So it doesn't exist under reason 1. Limit as x approaches 0 from the left of the function does not equal limit as x approaches 0 from the right of the function. So as you can imagine, we can probably come up with a scenario where the limit will match. So let's make an asymptote here. And we'll just have a graph that kind of does something like this then. Okay? If you look at the graph really quickly, does it seem like both of the sides of this function, both of the sides of this limit, if this is x equals 3, do you think that the sides agree? The left equals the right. They do. You come in from the left, you're going up to infinity. You come in from the right, you're going up from infinity. So I could say that the limit as x approaches 3 from the left is infinity. I could say the limit as x approaches 3 from the right is infinity. And I could say, since these are the same, I could say the limit as x approaches 3 is infinity. But here's the caveat. You have to then say DNE because infinity doesn't exist. Okay? And there's a little bit of a debate on this. If you put DNE but you don't put infinity on like the AP calculus exam, you sometimes can get away with it. Sometimes they set it up so that you really kind of have to have both. So you're showing that the limit does go to infinity. The limit would actually be infinity because the left and the right are both pointing up to the sky. But infinity doesn't exist, so the limit doesn't exist. So that's the second type of limit that doesn't exist. Okay? So that's a little bit of what we want to get into. We want to get into also like tables just for a second. I want to make sure that we know how to make a table. So let's talk about tables for a minute. So if we were to, I might go to the document camera actually, just because it's going to be a lot easier. If we were to try to make a table with a limit problem, what would that look like? So let's see what we got. All right. Okie dokie. Oh, there we go. All right, so we flip it around, we focus it, and then we will try to talk about a table. Let's see if I can find a better one here. Nah, we'll just do the one we'll just do number 1. Okay, so this is the problem I want to do right here. I want to talk about this problem. So if we talk about this for a second, let's just look at what happens at all of these values. Well, the first thing is that you're going to need to figure out how to make a table with these. So if you have a calculator, it would be a good idea to take it out. I'm going to go to, I think it was, okay, so somehow this got paused, but now we're back. So who knows what we missed? Very sad. Okay, so we're going to try problem 1 on this. If you need to pause the video, feel free. This is called Sage Calc. It basically just gives you a TI. And what we want to do is we want to put in this function here, which is x minus 2 over x squared minus x minus 2. So we want to put that in. So just bear with me as I do that. So it's going to be alpha x, and then on the top it's going to be x minus 2 over x squared minus x squared minus x minus 2 minus x minus 2. Okay, so what I'm going to do is I'm going to go to second table set. Okay, I think you've probably seen how to do this, but I want to make sure that you know how to do this. So go to second table set, and you want to change your independent variable to ask. You're going to love this if you don't remember how to do this. Okay, we don't want to do that. Okay, there we go. So we change our independent variable to ask. When we go to second table, we now have a table with blank x's. So you went to second table set. It could be filled in with something random too. But now we can just type whatever x's we want. So we go back here and we type in 1.9 and 1.99. So if we just type in 1.9, it's going to give us the y value. Boom, just like that. It's giving us a fraction this time, but that's fine. I can change it if we want to a decimal. I don't really think it matters too much. So second table, 1.9. 1.99, 1.999, 1.9999. So we've just made a table. It doesn't give us decimals. You can make them decimals, or you can change your calculator setting. And now we're going to put in 2.001, 2.01, and 2.1. So 2.001, 2.01, and 2.1. So look what happened. Your calculator made the table for you. It has an error here at 2, which is not really ideal. I think I might have typed it in wrong. Let's see. Because it should have been 2.001. Let's see what happens. There we go. So you can basically make a table from your calculator. These would all be better to come out as decimals. But what do we see is mostly happening here? 10 over 29, 100 over 299. What are these numbers even meaning? What's the meaning of this? What do you think the y's are kind of hovering about? Anybody have an idea? 1/3. 1/3 is the limit. So what's happening is when we make this table, we can see that all of these are basically a third. We never quite get there. None of these are exactly a third. But as we come from the left, which is this side, this is where the limit is, right? And as we come from the right, I didn't have all the values, but you can see that these are kind of approaching a third. So the limit as x approaches 2, because it was going to be 2 right here, right, of that function is a third. Okay. Questions about making the table? Once you can make a table, you can basically just look at the pattern, and then there's going to be a missing thing, okay? So it's almost like you're walking, and then there's just like a manhole, you know what I'm saying? And you're trying to get right close to that, and then it just drops off, right? Or you're walking, and then there's a cliff, you know? We want to see what's happening as we get to the edge of that, right to the edge. And that's kind of all I wanted to talk about today. The 3 types that don't exist, just to get you like started with it, and then how to make a table so you can just look at some problems. So we're going to work on some problems. 2025, you guys, we're going to be on page 54, 55 in this different textbook, which is a calculus textbook, working through some limit problems. They should go pretty quick. So I will pause here or stop, and hopefully we didn't lose too much content in the middle there. We'll see you in the next video. Make sure you subscribe, like, comment down below, interact with me. Tick that notification bell, and we'll see you in the next video. Peace.